bit better about this overall.
This is our last monthly lecture.
This is.
So we'd like to see this.
You know, you don't have time to be sentimental at the end of the semester because you have so much stuff going on. But you don't realize until after you leave that's the last time you get to be in this class, and that's the last time. It's only next semester you're thinking about, yeah, I remember that stuff in the last class, or I remember how it was. So one of the things I like to do is I like to have my students added to my Facebook, because that's something that sustains itself long after you're out of college. So I pride myself on keeping in touch with my students. I still have students I keep in touch with that I had back in 1991. And I keep track of them, and I use that information later to tell people, look, I know that our students are having a hard time finding jobs, or I know that our students have been placed at this and this place because I'm still in touch with them. So it's great. So if you have your phone right now, it's a great time to connect right now while you're thinking about it. Once you finish here, you might not ever have me again, especially if you're a math major. And the only chance I have to see you is if you happen to stop by. So if you're walking through Richardson, say, look, I have 10 minutes between classes, I can't really get anything done in 10 minutes, I'm just going to swing by there and see if she's there. Do that. Stop in and say hi. Our final is Monday, May 12th. I have a confession to make. I'm not here. You might think I like to travel. I hate to travel. Unfortunately, it's stepping on me like anything. So I will have someone proctoring the exam. This will be the last time you see me as a teacher in front of your class, unless you take me again. And even if you take this class again, I'm not teaching this class in the fall, so it's easier second time around. I think everyone in here is passing, so it's just a joke. I have a friend, I don't think he's in academia anymore, but he might not be because he didn't take to teaching very well, but he always used to tell his students on the last day of class that this class is easier next time around. So what I thought I'd do, I didn't get any emails from you about what you'd like me to cover, so I thought what I'd do is just go over all the exams and quizzes and pinpoint those things that I thought were the most mistakes were made on, and what I thought was going on in your head. I think as a teacher, anybody who's going into teaching, it's really an important thing to do, not to go beyond saying the student made a mistake, but to try to figure out where they made the mistake. And I often ask students, what did you mean by this, or what were you thinking when you did this, so I can get in there and help resolve that issue. The thing about mistakes that's really interesting is, I think I've told you this before, that students who make the mistake, even if you show them where they're wrong, they continue to make that same mistake in the next exam. So it's really important for you to go back through the mistakes and maybe even watch these little videos that I'm making right now right before you sit down to study, so that they're in your head. I ran an experiment with graduate students a number of years ago where they had to take a comprehensive exam. And I thought the best way to teach the class would be to make all the exams comprehensive and keep kind of compiling everything. What I noticed between the first and second test is I gave them 4 tests in that class, because that's what the end goal was, to take the comprehensive exams and pass them. And in between the first and the second test, I asked them to go through their test and look for all their mistakes and correct them. On the second test, they still made the same mistakes they had on the first test, even though they'd seen the correct answer and even though they've corrected their test. So between the second and third test, what I did is I asked them to kind of fill in and think about why they made the mistake they made and how they would stop themselves from making that mistake in the next test. There, I got them. So the next test, when they came through the third test, they actually did resolve whatever issue they had and correct it. But that lets you know that there's something about how we walk into something or an exam, or how we thought about something, that we just revert back to that instead of correcting it in our own minds. And these were graduate students, and many of them were already high school teachers. So these are not, stupid people off the street trying to take a math exam. They already had their math degrees, and many of them were already teaching. So I went back to this problem here, which has appeared on actually a number of the exams, and most people are getting this correct. But I think the piece that people get incorrect is using the definition of span to arrive at the answer. So you could look at this problem as completely procedural, which is useless. it doesn't really mean anything. The important part of this is using the definition, realizing what the connection of this problem is to span. And I liken this to, believe it or not, I can hit balls out of the park. I used to go to batting cages all the time and hit ball in the fast cage. The fastest cage, I sit there, slam ball after ball. And people used to ask me, hey, why don't you go and play on a team? Well, I can't. I've never actually played. The procedure of hitting a ball, I can do that. It's just procedural, but it's completely useless. Right? Until I actually use it in a game, it wasn't really useful. So it's similar to that. It's a procedural thing, and I don't really want you to memorize procedural things. It's a waste of time. So what were people thinking? I think they were thinking about the procedure and not thinking about what they were trying to do. So don't think about the procedure. Start with the definition of span. So what is the span? And I call this now the Tyler. It has been officially named the Tyler. If you don't know the definition of span, then you're kind of stuck right there. You can't answer anything. That's the definition of span. The span of these two vectors are the set of all linear combinations of those two vectors. And this is how we write it in set formation. And I've encouraged you to write it this way because you need something to grab your hands onto. So for B to be in the set, it's got to be a combination of those two vectors. And I used an x1 and x2 to distinguish from the c1 dummy variable c1 and c2 I put in here. You're really looking for weights. They have to be answers to those weights. Well, if there's weights like that, I should be able to solve for them. So the question really is revamped, is do those weights exist? If those weights exist, then the answer is yes, it's in the span. If those weights don't exist, then it's not in the span. You may never know. Maybe on the final exam I'll throw you one where the weights don't exist. Right? It's that. I mean, that would be a way to really dig at whether you know the definition of span or not. You set it all up and find out the x1 and x2 don't exist, and the answer is no. There's no solution. So you just set up the equations, and now we're into the procedural part. But at least we have a reason for doing what we're doing, rather than me sitting there for hours and slamming a ball in the fast cage for no reason. It felt good. So that first part is solvable. And I just stuck it on Maple. You can use matrices. You can use substitution method from high school, whatever you want. I stuck it on Maple, and I got x1 equals -7 and x2 equals -2. And then I can use that to solve for h. And I get a solution. And this is all going to be on YouTube, so if you don't catch up with my voice. Make sense? If that breakdown's missing, I do have it on the rubric. I will take off those points on the rubric where I specifically ask you to use the definition of span and break it down. So go for understanding on this problem. It's appeared on several tests now, so you can go back and revise it, and you can watch this video. I think it'll help. Question?
When it says on the right side, show it as a span of vectors. You can't use just the two vectors and the x2 and x3 when you found it in the problem. You have to do it as with the brackets.
I think what you're asking
base
is,
vectors.
can't I just start here? Can't I just start here and solve the problem? But as a teacher, I would like to know that you know that what this is coming from. If you don't know whether this is coming from, I can bet within a month, maybe less, you're going to forget this procedure. It's just a procedure. I'm not really convinced I can go to the batting cage right now and hit the balls very hard right now. I haven't done it in a long time. It's just a procedure, right? So it's useless. That means the time you've spent in here is useless. So asking this question from here on out doesn't show me that you understand anything. But if you explain it back from here, it's very clear what this is about. Well, here's the span. This is the definition of span. That is it. That's a span of two vectors. And I stay in the next statement for B to be in the set. B has to look like something in that set. That means there has to be weights. So going to here, that I wrote it there, do these weights exist? If they exist, then they're in the span. If they don't exist, they're not in the span. So I'm really in search of those weights. So now I have a clear definition of why I'm setting up this procedure. And remember that 1.1 or wherever it was in the beginning of the book was about row reducing. That's a procedure. By itself, it's pretty useless. You've used that same procedure all the way through to figure out how to do other problems. We use it all the time, all the way up to eigenvalues and eigenvectors. We've been using that procedure. It's the use of the procedure that makes it strong and useful, not the procedure itself. Agree?
So what would it look like if it's not this way? 'Cause I feel like since there's
You would get something to happen right here where it would give you an inconsistent solution.
so
Right? You
if
wouldn't
I
be able to
want
find the
one
weights, right?
together-
The weights have to exist for it to be in the span. Make sense?
Yeah, because I was just gonna have to run because it's a variable, so it could be anything. But the first.
Yeah, once I found the weights, I found them right here. X1 equals minus, so now I know that this vector B has weights that put it in as a linear combination so it fits inside that span. So I've actually demonstrated, here it is, -7, take C1 equals -7 and C2 equals 2, and it's a member of that set. If I couldn't find any weight to work, then it's not a member of that set. Make sense? Any other questions? Okay, be patient with me, otherwise we can't save these. Where did it go? Don't tell me it wasn't taped. Yeah, I saw it count down too. Oh yeah.